So there are a number of different ways to actually measure concentration, but the one that we're going to be using in this class is molarity.
So molarity is instead of volume or mass, it's the moles of your solute divided by liters of your solution. Okay? The units for molarity are capital M, okay? And that's pronounced molar. So if I have a 10 molar solution, that's describing the molarity. Okay? So for this problem, it says calculate the molarity of a solution that has 0.127 moles of sucrose in 655 mils of solution. Okay? So here I already have my moles of solute. In a lot of problems you'll be asked, calculate the molarity of a solution that has a certain number of grams of solute. So in that case, you would have to convert from grams into moles. But here I'm already in moles, which is awesome. So my molarity equals my moles, 0.127 moles, divided by, well, I need to be in liters of solution. So I'm going to take the 655 milliliters, and I'm going to convert that into liters. If you can do that in your head, awesome. If you can't, that's fine. But get used to needing to do that conversion because it's going to happen a lot. So they're 10 to the negative third liters in 1 milliliter. Okay, so I'm going to just end up dividing by 1,000 because that's what multiplying by 10 to the negative third is. So what I get for my volume is 0.655 liters. Okay, so that's what's going to go on bottom. That's my volume of my solution. Okay, and so what I get for my molarity when I do this, 0.127 divided by 0.655, I get, well, I want 3 sig figs here. I've got 3 sig figs here. So I got 0.19389. So I want to keep the 1, the 9, and the 3 is going to round up to a 4. So 0.194. And my units are molar, capital M. Make sure it's a capital M and it's molar. And that's it. Those are your molarity concentration calculations.
So in this lesson, I'm going to explain how to create specific types of solutions. And so the first type of solution is if I go into my prep room and I've got a solid and I need to make an actual solution. So let's look at an example and see what I'm going to do. I want to create a 1.02 molar solution of glucose, and I want my sample to have a volume of 105 milliliters. So you guys have actually learned the math for this already. You're going to be using your molarity formula. And so specifically, I know my molarity is 1.02 molar. I know my volume. Remember, it's got to be in liters of solution, so that's going to be 0.105 liters. And I'm solving for my moles. So when I solve for this, I get 0.107 moles. Now it's asking for me to actually create this solution. Well, I can't measure moles in the lab, so I need to convert this into grams. So I'm going to put moles on bottom, grams up top. And I'm going to put the molar mass of glucose on top and 1 mole on bottom. And so when I do that, I get 19.3 grams. So in order to create this solution, I'm going to take 19.3 grams of glucose and I'm going to add it to water. So I'm going to, in a container, I'll have a little bit of water. I'll add 19.3 grams of glucose just to dissolve it. And then I'm going to add enough water in order to get a final volume of my solution of 105 milliliters. Okay? So this isn't new. The only thing that's really new is knowing that in order to create a solution, you're going to add a little bit of your solvent first, then add your solute, and then get a final volume of whatever you wanted. The next type of creating a solution is a dilution. So this is new. This is when I have a concentrated solution. So in the back, let's say I have a 6 molar solution of hydrochloric acid, and me needing to create a less dilute solution. And so the formula I'm going to use for this is M1V1 equals M2V2. Okay, so for example, my M1 would be my concentrated orange juice. Okay, and so I've got a volume of just 1 can. So my M1 would be the concentration of my concentrated orange juice. My V1 would be 1 can. My M2 would be, well, I'm going to need to calculate whatever the concentration of my final orange juice solution is. And the volume is going to be 4 cans because I have 3 cans of water and 1 can of orange juice. So that's my V2. So let's look at an example. It asks me to make 2.5 liters of a 0.100 molar KCl solution if my stock solution is 5.5 molar. So my 5.5 molar is my concentrated solution. So I'm going to M1V1, M2V2 it. My M1 is 5.5 molar. That's my concentrated solution. And I don't know how much of that concentrated solution I need. So that's my V2. That's going to equal 0.100, which is the concentration of my solution once it's been diluted, times the volume that I want, which is 2.5 liters. So when I solve for this, I get 0.114 liters, and that's 0.114 liters of my stock solution, my concentrated solution. So since 0.114 liters is, I don't tend to measure that in the lab, I'm going to convert that into 114 milliliters, okay? And so what I'm going to do is I'm going to add a little bit of water to my graduated cylinder. Then I'm going to add 114 milliliters of my concentrated KCl, and then I'm going to add enough water to get the final volume at 2.5 liters. Now the reason why I don't first pour in 114 milliliters of my concentrated solution and then water is because my concentrated solution could splash when I pour water in. So instead, I'm going to add a good amount of water, then I'm going to add my concentrated solution, and then I'm going to add enough water to get a final volume of 2.5 liters. So that's two different ways of creating solutions. One, taking a solid, adding it to your solvent, and two, dilution.
So you guys just learned how to create solutions. So if you start with a solid, you guys learned that you have to determine the mass of the solid that you need, add it to a container, and then add enough water to get your final volume, the final volume of your solution. If you have a concentrated solution instead, what you have to do is use your M1V1 equals M2V2 formula, determine the volume of your concentrated solution, we also call that your stock solution, add that to a new container, and then add enough water to get the final volume that you're looking for. Now, we've been saying container, container, container over and over again. Now we're going to actually look at what the tools are that we're going to use to create these solutions. So when we're measuring volume, the absolute best tool that we have for measuring volume in the lab is a volumetric flask. Unfortunately, a volumetric flask can only measure one specific volume. So we have a 25 mil, 50, 100, 250, 500, 1000, and even we don't right now have in the lab, but sometimes we have a 2,500 mil volumetric flask. So if you're creating a solution that has those exact volumes, so if I want to create exactly 25 mils of a solution or exactly 1,000 mils, that is the best tool to use because it only measures one specific exact volume. If you need to measure a volume that is different from one of those volumes, then the best tool for you to use is a burette. Now remember, we used burettes when we were working with titrations. Now the burette can maximum hold 50 milliliters. So if you need to measure a volume that's greater than 50 milliliters, then you're not going to be able to use a burette. But if you need to measure a volume that's less than 50 milliliters, let's say for example 35, your burette is your best option since you cannot use the volumetric flask because I don't have a 35 ml volumetric flask. If I need to measure a volume that is greater than 50, the best tool for me to use is a graduated cylinder. Now, I have graduated cylinders of sizes 10, 50, 150, and 500 milliliters. Okay, so those three are tools that I can use for measuring volumes. What about measuring mass? Well, if I'm measuring the mass, meaning measuring a solid, I'm going to be using an electric scale. So let's go back to those two example problems and figure out what tools I would need to use. So the first example problem, if you'll go back, was about creating the 1.02 molar glucose solution, 105 mils of that. Okay? So keep in mind that the glucose is a solid, and so what I'm going to have to do is I'm going to have to use an electric scale. So we had determined that you needed 19.3 grams of your solid. So I need to weigh the 19.3 grams of glucose using my electric scale. Some other tools that you could use would be like a spatula in order to scoop it up. You'd use a weigh boat in order to put the glucose onto the electric scale. But the main point is in determining the mass that you have, you need an electric scale. Then I'm going to have to add it to a container. And that container needs to be able to measure up to 105 milliliters. So if you look back at the tools that you have, my volumetric flask doesn't work because I don't have a volume for 105 mils. Burette doesn't work because
105 mils is greater than 50 mils. So I'm going to have to use a graduated cylinder. Now, I have a 10, 50, 150, and 500 mil graduated cylinder. I cannot use the 10 or the 50 because those volumes are too small. I need 105 mils. So I would use the next size up, which would be 150 mil. So after weighing it using the electric scale, I would then add my solid to the 150 mil graduated cylinder. Once I've added the solid to the 150 mil graduated cylinder, I would add enough water to get a final volume of 105 mils. Okay, so that's how you create a solution from a solid. What about if I'm just diluting a solution? So here, we went through the math of this, but I have a 5.5 molar stock solution. I want to create a 2.5 liter solution that has a concentration of 0.100 molar. So after using M1V1 equals M2V2, we determined that I want 45 mils of my stock solution. So how do I measure 45 mils? Well, if we go back, keep in mind, I don't have a 45 mil volumetric flask, but I do have a burette because the burette measures up to 50 mils. So I'm going to measure the 45 milliliters using a burette. Then I need to add that to a container because I'm going to have to get a final volume of 2.5 liters. Well, do I have a volumetric flask that can measure 2.5 liters? I do. I have the 2500 mil volumetric flask. And so I'm going to take the 45 mils from the burette and I'm going to pour it into the volumetric flask. Okay. Then I'm going to add enough water to get a final volume of 2.5 liters. Okay. Keep in mind we don't measure the exact amount of water, and the reason why is it isn't actually additive. When you take a solution and you dilute it, the particles themselves can actually cause the volume to decrease based on how they interact with water. And so you're not going to ever add exactly the amount. Like for example, here, I would never take 2500 and subtract 45 from that to get the volume of water. It's not going to be exactly that. So instead, I simply say I'm going to add enough water to get the final volume that I want, which is 2.5 liters.